Alright, class, our next lesson is lesson 16.2. Which measure of center should you use? Determining when to use the mean, median, or the mode. So now, after practicing with those different measures of center, we're going to take some time practicing deciding when to use mean, median, or mode. So in this lesson we will calculate the mean, median, and mode from a graphical display of data and determine when to use the mean, median, or mode to describe a data set. I know a lot of you play video games. Chances are you already play video games, not just at home, but sometimes at school. You just don't think about it in the same way as you think about playing video games at home. I know the Mathia program has some games that you can play at the end of units. So video games can actually be very educational, whether you play at home or school. Some games can help with problem solving, and of course, they make learning more fun. So hopefully, when you answer this next question, how many hours a day do you spend playing video games? Hopefully it's not a ton of time. Hopefully when you go home, you're not just sitting in front of the computer or TV and playing video games, but depending on what you're playing, could be a good educational resource as well. So taking a look at problem 1, it says comparing the means and medians of two sets of data. It says previously you determined the balance points and calculated means of various data sets. It says graph the numbers 2, 3, 5, and 6 on the first line plot, and 2, 3, 5, 10 on the second line plot. Then place a triangle under the number line plot at the location that represents the balance point. So go ahead and do that now. Alright, taking a look here, after you've graphed the points for 2, 3, 5, and 6, the balance point would be 4. You can see that by 3 and 5, they're both 1 away from 4. 2 and 6 are both 2 away from 4. So the point 4 balances equally both sides of it, to the left and to the right. Whereas for the second one, where we have 2, 3, 5, and 10 graphed, 5 would be the balance point. 3 is 2 away from 5. 10 is 1, 2, 3, 4, 5 spots away from 5. And 2 is 1, 2, 3 spots away from 5. So if we take a moment and do a little, if we again add 3 to 2, that would get us to 5. If we add 2 to 3, that would get us to 5. If we subtract 5 from 10, that would get us 5. So the balance point, or in other words, mean, would be 5. So question 2 says compare the balance points and means of the two data sets. What happens to the mean when the data value of 6 is replaced with the data value of 10? So if we think back to those two problems, the mean for the first problem was what, and then the mean for the second graph was what. Okay, so what happened to the mean when that data value of 6 is replaced with 10? Go ahead and answer that now. When you're done, unpause the video. So obviously the mean increases when that data value of 6 was replaced by 10. It went from 4 to 5, which makes sense because 10 is much bigger than 5. Or excuse me, 10 is much bigger than 6, I should say. So then number 3 says calculate the medians for the two data sets. And then number 4 says what happens to the median when the data value of 6 is replaced with the data value of 10. So answer those two questions now. To calculate the median for the first data set, you first need to make sure your numbers in order from least to greatest, and then you need to find which value is in the middle. So 2 and 6 I can cross off, and then in the middle is 3 and 5. So to determine what's in the middle of that, there I can see that that is 4, but if we're working with a more challenging problem, this might be a little bit more difficult. So if I add 3 plus 5 and then divide that by 2, that will give me the median. So whenever you have 2 left over, 2 numbers or values left over, you can add them together and divide them by 2. So 3 plus 5 is 8. Find what's in the middle of that, and it would equal 4. If I do the same thing with the next data set, 2, 3, 5, and 10, again, 2 and 10, the first number and last number, are going to cancel. I'm left with 3 and 5. Same thing's going to happen. 3 plus 5 is 8. Divide by 2, that would be 4. So the median, again, is 4. So the median did not change because that last value changed. Go ahead and complete numbers 4 and 5 on your own. When you're done, unpause the video. For 5A, again, it says plot the data sets on the 2 separate number lines, so go ahead and plot those. And then B, it says to determine the mean, median, and mode for each data set by using the dot plots you created. And then you must explain how do you determine each measure of center. So a couple of things that you have to do. First, determine the mean, median, mode, and then explain how you determined each measure of center. So make sure you get both tasks done. When you're done, unpause the video. To start with the first data set here, I have the values in place 50, 50, 55, 60, and 60. The first one I'm going to start with is the mode. The mode, again, is the number that occurs the most in a data set. In this case, there are 2 modes, 50 and 60, both occur twice. So the mode is 50 and 60. So next, I'm going to look at the median. So again, the median is the middle number. Now this time, we are left with 5 values. So if we do the crossing off method, 50 and 60 can both be crossed off. Then 50 and 60 can be crossed off again. And the median would then be 55. Now, finding the mean, we have 1, 2, 3, 4, 5 data values. If we add them all up, 50 plus 50 is 100. 100 plus 60 is 160. 160 plus 60 is 220. And 220 plus 55, if that's tougher for you, you can make sure that you add that together. 220 plus 55 would be 275. Okay, so that's the total values. Now I can divide 275 by 5 to figure out the mean. So 275 divided by 5. 200s can't be split up into 5 groups, so that's going to be 0. I have 2 left, 200s left. I split those up into tens. I would have 27 tens, and there'd be 5 in each group. So that's going to be, let me erase this real quick. There we go, that's a little bit better. So we'd use 25 tens, and we'd have 2 tens left. Split those up into 1 so we can do something with them, and then we're going to have 5 ones in each group with none left over. So the mean is also 55 for that first data set. Now you could have also found the mean by finding the balance point on the number line by crossing off as we've practiced. And then you can look at the description for letter B as to how you can write a quality level response. For set 2, the mean would have been 50. Again, you could determine it by using the balance point or by adding the total values up and then dividing by the total number, which again was 5. And then the median, again, was 55. And the mode, in that case, was 60. Okay, because there's two 60s. So for number 3, or excuse me, not number 3, letter C, it says, what did you notice about the medians for each data set? What do you notice about the means of each data set for letter D? And then letter E, why do you think the medians of the data set are the same, but the means of the data sets are different? So go ahead and answer those questions now. When you're done, unpause the video. Alright, so what you should have noticed from the medians of the data set was that the medians were the same. In letter D, you should have noticed about the means that the means were different in each set. The mean of set 2 was less than the mean of set 1. So the mean of set 2 was 55, the mean of set 1 was 50. And why do you think the means of the data sets are the same, but the means of the data sets are different? Here would be a quality response. The medians are the same because the median describes the middle number in a data set. It's not affected by the values of the least and greatest numbers in the data set. The means are different because the mean is the balance point in a data set. If there are extreme values that are not close to the other values in a data set, the mean moves toward the extreme values in order to balance the data. So when we have a really, really high number, remember we called that an outlier, okay? An outlier can throw off the data, okay? So if we look back at our data set here with 25, 25 is much lower than all the other numbers, okay? So 25 kind of sticks out like a sore throat. All right, work on problem 6 and problem 7. When you're finished with problem 6 and problem 7, you can unpause the video. What you should have noted about the distributions of the two plots was the dot plot for set 1 is symmetric, the dot plot for set 2 is skewed left. So if we go back here, dot plot for set 1 is symmetric. You can see that there's two values on either side of 55, whereas set 2 is skewed left. There's a lot of data on the right hand side, but there's little data here, so where the 25 is. So it's skewed left, okay, because most of the data is to the right hand side. Alright, we're going to get rolling here with problem 2. Previously, you examined a data set about the number of minutes students at Sharp Middle School exercise. The data is shown here. Construct a line plot of the data. When you're done, unpause the video. Alright, this is what your dot plot or your line plot should look like. You can see that there's a lot of values on the left and just one value on the right. So if we look at letter B, it says Karen says this mean will be greater than the median in this data set. Do you agree with Karen's statement? Explain your reasoning. Here's your chance to justify your reasoning. Make sure that you are complete with your response and use good vocab. Again, unpause the video when you're finished. Alright, so in this case, I would agree with Karen's statement because the greatest number in the data set is 300 minutes, which is far away from the other values in the data set. Therefore, the mean will be affected by that data point, which is an outlier. The median will be closer to where most of the data values are because it is not affected by the 300 data value. And this is where I'm going to leave you for today. I'd like you to finish the rest of this page, 1085, and then take a look at 1086 for tomorrow. And we'll finish at 1087. So finish 87 for tomorrow. Thanks.